In this video, we're going to start working on multiplication using the standard algorithm. We're going to multiply 2-digit by 1-digit numbers and 3 digits by 1 digit. So we're going to start off pretty basic and low so we can understand the working of the way the algorithm works. That's why, and I have the place value chart here because we're going to multiply within the place value chart just to put an emphasis on the place value aspects of the standard algorithm so you can understand that. The goal is for you to become so efficient with multiplication that you don't even need to think much about place value reasoning within it, but we're going to make you think about it in the beginning just because it's important to know what's going on with the value of number as you multiply. Let's review quickly the grouping aspect of multiplication. So we're going to multiply 23 times 3. So another way to say that, or what we're really talking about, is this is 3 groups of 23. So I'm going to draw 3 groups of 23. If you watched videos of mine prior to this about the grouping method, we actually drew dots into these circles, but there are too many to draw 23 dots, so we're just going to represent it that way. But this is the same thing, 3 groups of 23. And multiplication is really just a better way of counting. All math starts with counting 1, 2, 3 until that becomes inefficient. Then we have a shortcut with multiplication when we can group things in equal groups. Then we can use multiplication as a faster way to counting, but we're still just finding the total amount, finding the sum. So basically we have, say, a pair of jeans that costs $23 and we want 3 of those same kind of jeans. How much is that going to cost us? So we have 3 groups of $23 that we need to find the total for. So we can add them up. This is a method called repeated addition, which you probably learned in elementary school or previously. We want to add all those up. 3 plus 3 is 6, plus 3 is 9, 2 plus 2 is 4, plus 2 is 6. So we're going to end up with a total of 69, and we know that. Now, grouping like this and repeated addition becomes, as you can see, really inefficient. We obviously don't want to count 23 one at a time over 3 groups. That'd take forever. This takes a little bit longer. So we need a more efficient method, and that's where the standard algorithm comes in. That's why we use a standard algorithm. There are lots of algorithms for multiplication. We're going to focus on the standard algorithm because it ends up being the most efficient in the end, and it has the ability to handle the most complex situations with the most ease. So we're going to use that. So we know that 23 times 3 is 69. We've already determined that. Now let's throw it into the standard algorithm, and maybe this is review for you. If so, that's great. 23 multiplied by 3. The way the standard algorithm works is it's a little bit different than addition in that in addition we line up everything and add straight down. In multiplication, we're actually adding all 3 things. We're adding everything 3 times, so we have to multiply this 3 times every one of these columns. So we start with multiplying the 3, which is a unit, its actual value is 3, times this other 3 in the units, so its actual value is 3. We know by fact fluency that 3 times 3 is equal to 9. Easy enough. Then we move over and we multiply this 3 times the 2. But we also know, and this is why I wanted to put this in place value chart, that this is not worth 2, it's actually worth 20. So it's 3 times 20, which is 60. We don't need the 0, so we would put 60. The 0 plus 9 ends up being 9, so we don't actually have to put the 0 here, but it's important to understand that 3 times 20 is 60. That's why the 6 goes here. That's what determines that. It has a value of 6 times 10, or 60. So our final answer is 69. Now let's take a look at one more example. We're going to ramp it up a little bit with a 2 by 3, or multiplying a 3-digit by a 1-digit number, and we're going to multiply 342 times 2. And again we have, and you don't have to show this, but we have 2 groups of 342. So that would draw out like this. There's 1 group, there's 2 groups. And we're going to add them up to get their sum. That's one way to do it, but it's inefficient, so we want to use the standard algorithm to do this as quickly and as efficiently as possible. And part of what comes with efficiency is when we start adding bigger numbers like this is there's a high likelihood of making mistakes. So we want to reduce the potential of mistakes. Just another reason that we want to use the standard algorithm. So we're going to take 342. Again, I put it in the appropriate spot. 300, 4 times 10 is 42, times 2. And we're going to multiply those using the same process as we did before. Again, with multiplication, you multiply each digit in the bottom number by each digit in the top. And that procedure will continue when we add digits on the bottom. For now, we just have digits, one digit on the bottom. So 2 times 2, they're both in the units place. So 2 times 2 we know is 4. Then we move to the tens place. 2 times 40 is 80. Don't need the 0 again because 0 plus 4 would give us 4. Always works that way. And 2 times 300 is 600. So 684. Again, we don't need to write the zeros because 0 plus 8 is 8. 0 plus 4 is 4. The zeros kind of come out in the wash in this process. So our final answer is 684, which is what we would have found if we'd have added 342 up twice. But again, this is just for demonstration. In the practice sets, you don't have to draw them out. Just wanted to remind you of the grouping aspects of multiplication. This is where it comes from. We have 2 groups of 342. To put this in a scenario, just so you can wrap your mind around that, say we have something that costs $342. Oh, do you like guitars? I like guitars. So we have a certain brand of guitar that costs $342, and for some reason I need 2 of them. Who doesn't need 2 guitars? So I multiply 342 times 2 to find the final answer. That's just an example of a potential real-life scenario. So there you have it. Pretty easy. In this practice set, there'll be nothing more complicated than that. So just work through it. Make sure you line up everything using the standard algorithm, and you should be fine.